I'm Alfred Spector. I'm the CTO at 2 Sigma, and I'll be introducing the talk and making some comments at the end. I have with me doing most of the presentation on the talk 2 of our engineers, one in our overall cloud engineering team and one that is focused on security engineering in the cloud. Focused on security engineering is Nick Arvanites. He is been with us and just done a tremendous job facilitating the connection between systems and security, something that's critical for all of us as we move into the cloud, and we are grateful he joined us. Jacques Klophosch has been with 2 Sigma, I don't know, about, what, 2 years? 2.5 years? 2.5 years, with background in cloud and systems at other companies, and has also been someone who's implemented much of our security controls and other strategies in our cloud computing. So they really know what needs to happen, and they've had experience not just with Google, but very broadly with cloud computing. Before I start, I have one very important message. I understand your seats fully recline. So I have never given a talk before where seats fully recline. So we will measure ourselves. If everyone's seat is reclined at the end of the talk, we will not be invited back to Google Next, I understand. So try to stay at least moderately vertical here in this presentation. All right, let me just talk a little bit about 2 Sigma in this now. So 2 Sigma is a financial firm and a tech firm both. Broadly, our mission is to get huge amounts of useful, indicative, privacy-preserving financial data, to draw inferences from that and to optimize economic outcomes. We're certainly known as a hedge fund, but we do a lot more than that. For example, we are using data now in a very rapidly growing insurance operation where we're looking to greatly almost revolutionize the way that small business insurance is done to assist in capital formation and reduce overheads, et cetera. In any case, we have very broad and interesting challenges in our space. We collect almost a petabyte of data a month, so it's a fairly large operation. And to do this, we feel that we need to be a tech company as well as a finance company. And that's a complicated balance to achieve. We can't be at the back end of technology as some finance companies have traditionally been. Otherwise, we won't have the talent to be at the leading edge of our industry. But if we adopt every new tech thing without concerns, we have $55 billion in assets under management, lots of regulatory structures and the like. So we have to actually be quite careful as well. We're about 1,500 people, roughly speaking, half engineering in the firm. So it is really a fascinating question in the security realm. I think the hardest realm of all in the space of IT or computer science is how to create an environment that's incredibly flexible and that has appropriate levels of security. One of the things we're most concerned about, not the only thing, but one of them, is the concern about how do we grow as a firm without the risk of data loss growing proportionally with the number of employees that we have. And we want to do that while still having a lot of interaction among our employees internally. So without having to wall them off from each other and prevent sharing, without having to wall them off from new technology or the internet, to allow for this fluid environment where we can actually have sort of our cake and eat it too. And that's the really interesting problem. I suspect that's a problem for many of you in this room. And we're going to be talking about part of that in this presentation today as we talk about how to do cloud computing in a way that doesn't have a significant risk of exfiltration. One more comment to make. We're really interested in how do we make our whole ecosystem more secure and vibrant. That's why we're giving the talk. That's beneficial to us. I think it's beneficial to others in our industry and broadly to cloud computing and to Google as well. So we're doing that in the hope that we can share best practices. We're giving, I think, 4 more talks on security over the next 2 days. You can find them. In fact, we'll put up a slide at the end on other talks that we are either giving or participating in. We're also giving a talk on serverless distributed computing in the cloud tomorrow. And also, Jacques is involved in giving a talk on Halite, which is a fascinating AI programming competition. We think it will be the largest term AI programming competition yet run in the 3rd incarnation this year. And it explores very interesting problems, not just about how to get artificial intelligence bots to do as well as people, but to actually do things that people could never do before. So self-driving cars, they're interesting, but we people do cars pretty well. We have to look at problems that are harder than what people can do, certainly in the investment management realm. And Halite begins to get at what can we start doing with computers that we can't even conceive of doing as humans. All right, without further ado, let me turn this over now to Nick, who will begin the more specific parts of the presentation.
Thank you, Alfred. Very briefly, Alfred touched a little on some of our challenges and our threat model, so I'm just briefly going to recap some of the key points there. Those things really drive the way we think about security and security controls. I'm going to hand over to Jack to talk about our evolution and our journey along the path and heading into Google Cloud. And then I'm going to spend quite a bit of time talking about how we work tightly with Google to build native security controls and implement those controls, and then finally wrap up with a few lessons learned. So a point that Alfred underscored, and I just want to quickly reiterate, is that our attack surface is very different to what you'd imagine for most organizations using cloud computing resources. We don't have anything consumer-facing. We don't have to be up and exposed all the time and worry about DDoS and things like that. Really, what we're focused on is internal use cases, use of managed services, processing data. So we have a very sort of inside-out attack surface compared to most organizations. Alfred mentioned how key intellectual property is for us. And really, when we think about threat models and risk mitigation, this is the factor that drives a lot of what we put into as considerations. And when we design controls, we want to protect our IP. Again, that's difficult to do without hampering people's workflows. We don't want to take away access to data or systems or segment people from each other so that they can't collaborate. So mitigating insider risk is really difficult. And one of the things that's worth highlighting is people talk about insider risk, and the immediate stretch is we don't trust our people. And that's not the case, right? We definitely want a model where one single person is not in a position to completely be able to exfiltrate data or code. But that also happens accidentally. And if you followed the thread of how sophisticated attackers target organizations, really what they're doing is they're targeting individuals with legitimate access and then using that compromised individual's access to move laterally, access their data, and ultimately exfiltrate that data. So when we think about insider risk, we think about all of those cases. We're not just thinking about malicious insiders, and that's an important point. Finally, we're not beholden to many of the regulatory considerations that a lot of organizations working in the cloud are, like we don't process payment card data, we don't necessarily have PII or HIPAA considerations, but we are very strongly consistent about what our compliance team is interested in and mandating that certain aspects of our business don't necessarily have access to data that other businesses are working on. And this can even go a little further in our research teams, right? We're very cognizant of researcher IP, and in some cases you may have researchers in the same team working on the same data set, but not able to view the output of each other's model code. That's really important to us, so we think about that as well when we're designing controls. So Jack will talk a little about our journey into the cloud and some of the challenges we faced.
So like many of you, we had a dream, and our dream was to connect directly with the cloud, to have a truly elastic internal infrastructure that extended to an external infrastructure. And for that, we, like many of you, looked to Google. Of course, unfortunately, when we started, Google was in its humble beginnings. And IAM wasn't exactly everything that we wanted it to be. It was very primitive, and so much so that they only gave us 3 primitive IAM options: owner, editor, and viewer. And unfortunately, that disallowed us to go more broadly into the scope that we wanted. We wanted things that were more granular. There were things in each of these that we desired and things of them that we didn't, and we wanted combinations of them. So at that point, because of that desire, we were unable to jump into that space, and we decided to wait a little bit until it was a little bit more mature. And when it started getting more mature, we finally reached the point that we felt was enough for us to actually jump directly into Google and be kind of happy with what we had, with some changes that we'd have to do. And Google, as it stood at that point, actually had very, very good services. And it did everything very, very well, but it was, again, in its beginnings, and Google does this iterative model really well in that you can think of it in terms of a car. If you're building a car, you build really good wheels, and then you build a really good steering wheel, and then you build the seats, and then you build the chassis. You don't just make a bad car, you make very, very good little parts and you put them together. And we wanted in at the beginning of that, so we had to deal sometimes with driving a car with just wheels. So when we tried to make our first connection, we saw all these amazing services that unfortunately were all directly connected to the internet. And we could use them, and then we'd have an open gateway, which is not what we desired if we're trying to block exfiltration risks. So we either opened up or we didn't use anything, and we just had VMs everywhere, which we could really do without Google, and that's not what we wanted. On top of that, we didn't really have a direct connection to Google at that time. Direct interconnect didn't really exist. We were in a type of connection that just went into the Google fabric, but not into what we wanted, into our projects. And that inherently meant that we had to do something about that, in which our case was more to try to get a VPN connection in there, and that required a lot of tuning from both sides. And we didn't really need the level of speeds that most people need when they're doing VPNs. We needed much greater speeds. Most people, when they think about it, are talking about megabits, megabytes per second. We're talking about many gigabytes per second connections. And of course, on top of all of that, Google had these nice bonuses that were actually really cool and really useful. The first time, for example, we saw Cloud SSH, we were in love with it. The idea that we could just directly connect to something. And we didn't really cared that much at that point to that specific exfiltration risk, because at that point, exfiltration is at the speed of typing, and you can do that in an email. So that wasn't a problem. Of course, problematically, we found out that there were extra features that, again, a boon to many to us weren't that useful, such as the upload file directly button in the Cloud SSH. Other things such as serial port connectivity. Serial port is an amazing feature if you have network problems. You connect directly to Google, you forego all of your firewall rules, you forego everything, and you just connect. Doesn't matter if you have an external IP or not, which of course we didn't really want. And it was either go or not go for that. Service accounts, another amazing feature from Google, also brought about quite a number of risks. They come with refresh tokens that didn't expire and could be reached from anywhere without any IP restriction, and they were a short string that you could just write on a piece of paper and take out. And on top of that, there was no egress firewall. You could just send data outside as much as you wanted. And there were also a number of overloaded calls at the time, which again, it's great, it's Google magic. It means that, you know, in very few steps you can do a lot, but at the same time for us, it means that we lose some of our protection. For instance, one great example is we had the IAM connection directly to BQ Select, BigQuery Select, which also allows you to export data. So you either didn't select things in BigQuery or you exported data. It wasn't a clear selection within them. So how could we target all of these things at once? And for that, originally we proxied everything. So everything we had to do had to go through these two proxies, one which we called the provisioning agent and the other one which we called Takoyaki. The provisioning agent was basically a strong precondition checker with ordering logic. So it was a direct REST command that kind of mapped to some of the Google ones for things that we trusted and we knew wouldn't change over time. And held a very, very privileged account to do all those things and to change projects. And it only did things the right way in the right order, such that in no step anything could be ever compromised if anything went wrong. And if anything went wrong, it did everything backwards in the right order. And it made sure that no one called things that they couldn't, such as creating an image with a serial port open in it. Conversely, Takoyaki, our other tool, which is kind of just a big joke, a big pun that we made, because originally it evolved from squid, and Takoyaki is really, squid well done because it's fried. It it checked REST calls for specific commands and allowed us to really be allow us to integrate directly with G-Cloud, because we could just allow some commands and deny other commands. And it also injected the tokens into the call so that we didn't need to worry about people just taking them out because they didn't have access to them. And of course, both of those meant that anytime anything changed, we needed to change everything in our end. Of course, Google was awesome and upstreamed a lot of the things that we needed changed, but for a lot of time, that wasn't great. On top of that, there's Google magic. You ask for something, Google goes poof, and it's solved. So for things like the serial port access, we talked to them, and they made changes that allowed us to really just turn it off. Or one other specific example, we had what we call the image exfiltration hack. At one specific point from one day to the other, again, Google went poof, and we had this amazing feature that actually allowed you to just move images from one project to another, which is actually very useful, but again, not that much for us, because suddenly that meant that we could have a very locked down project with images with very, very strong IP that you could just copy anywhere and then just exfiltrate if that other project was open. Again, Google went poof again, and we had a button that allowed us to turn it off. And on top of that, we had to add a little bit of our special touch. So things like SAML that allowed us to connect directly to our IDFS, which meant that we could log in only from our internal system there. So really, it was protected from external people. Our OS was custom, so we removed a lot of the Google SSH stuff that could also provide some risks. For things like G Suite, we added proxy headers that only allowed us to go to our own G Suite things and disallowed exfiltration. And we had our own proxy black magic for everything else. Of course, all of those brought about some hardship and struggle, in the sense that the VPN, as I said before, was expensive, not just to buy, but also to maintain. Any change, any increase meant that we had to have some very, very hard communications with Google to change everything. We were doing a lot of duplication. We're doing a lot of work that Google would end up doing afterwards anyway. And thankfully, again, they upstreamed a lot of what we did, so it wasn't for nothing. But they definitely do it better than us. So why should we do it? And ultimately, to ensure that everything is correct, we had to figure out all the undocumented endpoints and all of the undocumented IAM statements, which we still recommend that you do, but it's still a hardship. And now, back to Nick for a brief philosophical interlude.
Thank you, Jack. So the challenges that we had were in part driven, as Jack mentioned, by us wanting to enable this velocity and wanting to enable people to harness the power of the cloud, but also having very definite security considerations and security controls. We did go into this eyes wide open that we were iterating, but as we were iterating, we were racking up a lot of tech debt. And one of the things that I believe very philosophical that security teams should do is, to the quote that Rich Smith gave when he was the director of security at Etsy, security teams really should be enablers for the rest of engineering and for the business. Right? Anytime security becomes a blocker, ultimately your security posture will suffer because people will find ways to root around you. And also you'll lose credibility because you're no longer a business enabler. So the steps that we'd taken, while they were really great at getting us into the cloud really quickly, we fully understood that we picked up this debt and we were causing this kind of friction for the rest of our business teams. And we really wanted a way to resolve these issues in a very cloud-native way. It seemed like we were doing things the old-fashioned way, and this wasn't an ideal state for us to iterate quickly and to move faster. So we sat around and we thought about how we could address these issues. And at this point, it was really clear to us that as a design partner with Google, a lot of the value for us would be in surfacing these issues to Google. Right? As a partner, we had to surface our concerns, and we had to talk to them and understand what was available for us to address those concerns, or what was potentially roadmapped so that we could make the right decisions around investing in mitigating some of our risks in the short term, or actually just holding off, but making sure that we weren't engineering things that weren't going to last and were just destroying engineer productivity. One of the things that was also value added from our perspective to Google is, as we heard this morning, to paraphrase from Diane about Google's mission statement, Google exists to organize the world's information and make it easily accessible. In our case, we really wanted to do the opposite. We wanted to organize as much data as we could, but not make it accessible to anyone outside of 2 Sigma. So this perspective, whilst not unique to our industry, was a little early for a lot of the Google Cloud understanding, because most of the massive adopters are consumer-facing organizations. The services are built to enable somebody to iterate really rapidly and put things out there. So we thought this two-way conversation would be really helpful in terms of, as partners, us informing each other and then developing native controls. So I'm going to talk a little more in depth about some of these controls and some of the ones that are relevant to us and the journey that we had. And in this specific use case, I just want to point out that obviously security is multiple layers in the stack. So you have to be concerned about application security, host security. Right now, I'm not going to talk about any of those. I'm just going to talk about the cloud native services that we use to protect the Google Cloud. Likewise, Jack touched on G Suite. I'm not going to talk about that either, because that could be a whole talk by itself. So the first control that was really helpful for us was organization policies, and still is today. Many of the risk factors that Jack had talked about, bringing up VM instances with external IP addresses, the serial console access, things like being able to configure which of our projects was the source of truth for images that could be used in other projects, because we were using our own custom images. And then conversely, the flip side of that is making sure that the custom configurations that we were baking into our own images, we didn't want those to just be usable anywhere, so also being able to restrict where those were used by policy was important to us. And of course, another important policy is the fact that we could configure that only trusted user principals from our domains that we wanted to allow could be added to any Google resources. Right? And organization policies allowed us to do all of these things very powerfully, very minimal work involved, and we could configure them at any level in the hierarchy, from the organization itself to specific folders to actual individual project levels. Like, that gave us a lot of power. As Alfred mentioned, I'm talking a little more about organization policies and the specifics of what we configured in a talk on Thursday with the GCE team, so we can go into a lot more depth there. But these are a really powerful control, and we evolved a few of these together with Google. And one of the lovely things that happened was all of the manual things that Google had to do for us on the back end, organization policies eventually replaced those, and they were completely configurable and transparent to us. VPC Service Controls is another huge one. This one I really can't understate the importance of for our business. In the context of this talk, data exfiltration is, again, our biggest threat vector and our biggest consideration. And VPC Service Controls really allowed us to really extend the use case of the Google Cloud in a safe manner, which allowed us to then protect our data. So VPC Service Controls as a concept is an interesting one. If you think about an analogy of traditional systems and network security, you can really control your perimeter in a Google Cloud VPC. You have complete control over how you set up the routes. So as we do in many of our projects, you can just strip the internet route entirely. You can also control firewall policies, both ingress and egress now that that's available to us. What do you do with API access? Right? If you want to configure and work with managed services, which really is a lot of the value of the Google Cloud, things like Google Cloud Storage, BigQuery, being able to work with those APIs, but also protect your data and make sure that your data is contained, that's a really significant problem. And it led to us having very complicated workflows. Again, in the spirit of not wanting to block innovation from one of our teams, what we did was we ended up having an environment that we created that was completely standalone and not connected back to our internal network. We had a very convoluted path with which the researchers and the engineers in that team were able to access that environment. And in there, they had home servers that they could then use to access services like BigQuery, GCS, Dataproc Dataflow, and access the internet. The problem there was, from a security perspective, we had to maintain two different identities for these users, right? One was their actual identity that they could use from within 2 Sigma, where we had to do a ton of research and engineering and have proxies and all sorts of other things to ensure that that was a read-only type role where data couldn't be pushed out. And then we had to maintain a separate role for them that was tied to their home servers with which they could use these services with abandon. And that's not ideal, right? You have researchers and engineers with duplicated environments. They're not comfortable on their own servers. They also couldn't do things like work on external data sets and then join those with internal data sets within 2 Sigma and really unlock the value of research in that way. So what VPC Service Controls allowed us to do is now we can unlock those workflows. So at this point, we have a situation where we have an environment configured where a researcher within 2 Sigma can work on their own research environment, on their own servers, their home servers, and they can natively access services like Google Cloud Storage and BigQuery. And the power of that is incredible in allowing our researchers to really use internal data sets, external data, and accelerate research without producing massive, complicated infrastructure. Again, there's a lot of nuance to VPC Service Controls. There's another talk that I'm speaking in with that product team on Thursday as well, where we'll talk about more of the mechanics of the technical depth of it. But this was a really key thing where we worked very tightly with Google. The collaboration was huge. It was conceived here a year ago in some meetings Jack had over lunch with Samrat and some of the product team. And we've collaborated really closely over the last year and seen the product evolve. We used it extensively. We pen tested it. We did a lot of research on it as early access adopters. And really, we even contributed to some of the evolution, things like bridging of zones and some of the more complicated scenarios and representing our own internal network as a zone for VPC service control. So a lot of depth there, but this is one of the massive things that unlocked a lot of velocity for our business in a very, very safe manner. Jack touched on our woes with VPN connectivity. Dedicated Interconnect now really gives us private dedicated connectivity to the Google Cloud. The bandwidth we have is huge, and we no longer need to tax our internet proxies. We no longer need to maintain really complicated policies for a lot of use cases on those proxies because the connectivity is private. And this, coupled together with the VPC service controls and some of the other things I talked about earlier, really has been instrumental in creating that environment that's an extension of our internal network and the tools that researchers are comfortable with, and enabling us to really accelerate the use of the cloud across our business. Once we had that initial use case proven out, a lot of other business units within the firm are really now interested in how they can adopt these services using this private connectivity. So that was a big thing for us. Finally, IAM Conditions. Again, this is a very important element in our overall security posture. We believe very strongly in defense in depth and layered defenses. And IAM Conditions really allow us to complement the very coarse-grained access control that something like VPC Service Controls gives us with a very, very fine-grained and super granular set of conditions where we can meld those together. So right now, I can't talk in too much depth about IAM Conditions because there's a talk on it tomorrow, and some of the features are going to beta tomorrow. But if you do want some depth, again, please reach out to the product team. Chris Law, the product manager, is fantastic. What I can say is that IAM Conditions allows us to now take some of the principles that VPC Service Controls give us for things like controlling where we want to allow access to APIs from, and actually embed those into IAM in some cases where VPC Service Controls may not be the right solution, or in cases where we want it as an additional layer of depth in our defense in depth stack. So really powerful again, and really helpful in terms of Google listening to our concerns and really building solutions that enable these and allowing us to adopt these early and test them and help with the iteration. Like, those things are super valuable. So again, over the years, it's almost been hammered into security people that no matter how much you focus on prevention and trying to keep bad things from happening, there's an adage that if you think you're not compromised, you've probably been compromised for a while and just don't realize it. In terms of complementing that security posture, it's important to also have detection and response controls. And Cloud Security Command Center, again, is a very cloud-native product from Google that allows us to have a single console and a single interface with which we can monitor the security posture of our Google Cloud. Again, we were very early adopters. We worked very tightly with Andy and his team about CSCC. We helped it evolve. One of my colleagues is speaking on how we actually use CSCC in terms of monitoring our security posture for the cloud. But again, this is a lot of the security teams that start to move towards the cloud. You see this kind of mindset of we want to replicate the security stack and the security controls we have on-premise in the cloud. And that's really the wrong way to think about it. Right? The problems are fundamentally different. If you think about, and anybody here who's a user of the cloud, you know that the scale of the cloud and the pace of adoption is huge compared to what you have on-premise. And again, you'd be creating tech debt, you'd be creating suboptimal solutions by trying to bring everything back in-house and put it in the same console. And sure, there is some value there in having a single pane of glass, but really, if you're thinking cloud natively, you want to use cloud-based solutions to deal with the cloud. And Cloud Security Command Center is a very strong, evolving technology in that space, which we're really excited about. As a cousin to CSCC is the open source project Forseti that Google sponsors. Forseti is really well used and contributed to by companies like Spotify. We contribute to it from an open source perspective. It really is a powerful tool for us because historically, we had a model where when we were making changes in the Google Cloud, we'd go through a very strong upfront review process. You would review the code, we'd review the implementation, we'd go to deployment, and then things would be deployed, right? And who audits that infrastructure? Sure, we could audit it, but we have multiple projects. Auditing it manually is less than ideal. So this really didn't scale for us. What we wanted is, again, thinking in a cloud-native approach, we wanted a perspective where we could automate our security posture. We wanted to have a place where we could aggregate our inventory at any given point in time, and then apply security policy to that and validate that our assumptions are still upheld just in an automated fashion. So we deployed Forseti. Forseti was really helpful for us from that perspective. And actually a lot of the work that we've done is integrating Forseti so that when Forseti fires an alert, it'll actually be viewable in Cloud Security Command Center. And again, we're using the cloud to secure the cloud. And you'll notice I didn't talk at all about Stackdriver, about logs and monitoring. I think those are just a given. We're just talking about the next level of monitoring in the cloud, not the fundamentals. So we've talked about a lot of technologies and a lot of tools that helped us get to a decent security posture, but it's also important to talk about process. And I have a story that Jack will really will resonate with Jack and with one of my colleagues, Chris, in the audience. The way that we did deployments in the cloud historically also evolved over time. Back in the early days, we had a couple of people who had org admin privileges, and those were the people who you went to if you needed changes made. And that was okay, and it helped us iterate really quickly, but again, thinking about our fundamental security principles, that put us in a position where if that person were compromised by an attacker, the keys to the kingdom were right there, and they could do whatever they wanted. So that was less than ideal. So we took a step back and we thought about how we could try to mitigate that threat. And we came up with V2, and V2 was that nobody had org admin privileges anymore. We created one user principal who was our super org admin, and that user was used for break glass changes. And in terms of our security posture, changes that required anything to do with storage, or identity and access management, or networking configurations, anything that could open up systems or data, we considered those to be break glass changes. So what we did was we'd have a workflow where when somebody needed one of these changes, they'd submit the change request to us. The security team would review the change and approve it. And then what we'd have to do is we'd have to pair up with someone in the public cloud engineering team because they had the password to the super user account, and we had the corresponding security key, and then you had separation of duties, and you could make the change. And that was fantastic for us from a security perspective, but from an agility perspective, it wasn't great, right? There were so many manual steps. Ultimately, it culminated in you having two resources who were all really busy, and somebody was just sitting around watching somebody else type things or click around, which was really suboptimal. So again, we took a step back and thought about how we could use cloud-native technologies and our own processes to enable these workflows. And what we netted out at was doing a project together with Jack, again, where we built a solution for automated deployment. We built this in a manner that now when somebody wants one of those changes, they'll merge Google Cloud Deployment Manager template code to a source control repo. We'll review it and approve it and merge it, and that kicks off an event-driven CI/CD pipeline that will then have an artifact ready to be deployed. On the other side of that, because the security team doesn't know when the optimal deployment time is for an engineering team, it doesn't automatically deploy, it's just ready to deploy. And we have a UI that's protected by identity-aware proxy that then allows the user to log in and then hit a button to deploy their deployment. They can roll back, they can do all sorts of things. Again, Google enabled us to do this with their technologies like IAP, like Cloud Functions, like App Engine Flex, really, really powerful tooling and thinking about things in a cloud-native way. Finally, I won't hop on this too much, but least privilege is really critical to us as a core tenet. And again, Jack had spoken about where we started out with just the owner, editor, viewer. Today, we don't use anything but custom IAM roles. So anytime somebody needs to perform a workflow, or we have a new team that's onboarding to the cloud, we spend time to understand what each specific role within that business needs to do their job, and we craft an IAM role with exactly the permissions that are required for that and give it to that team. That allows us to also share those roles across multiple teams. Again, I talked about templates and source control. That's really powerful for us, and in the event that that user were compromised, we absolutely know what the impact of that compromise is based on what their privileges are. So again, custom IAM roles went to beta a while back, a really powerful tool for us, even over and above the curated roles that Google now publishes. So we talked a lot about very specific controls, things that we had to address our problems. Obviously, we only had 50 minutes, so there were a lot that we couldn't get into. But some of the quick takeaways in terms of lessons learned from our journey and our process, as if I haven't said it enough in this talk, it's really important to collaborate with Google. We work very tightly with our account team, our business manager, our TAM, our customer engineer are fantastic. But we also work really closely with product managers and with engineers. And again, I can't tell you how empowering it is to be working on a product and actually be on the phone or in a hangout with the engineers that are building that product. That sort of level of iteration really is what enables quick, like, velocity, acceleration in the cloud. That partnership is fundamental. So, and again, like, Google also needs to understand what your problems are in order to resolve them. And we've actually seen value not only for our own firm in some of the controls that I talked about that evolved through some of our issues, but also everybody else gets to benefit from them. So in the same way as it's important to contribute to open source, it's important to work with vendors and help them understand what the problems are in order to resolve those. Sandboxing is interesting. Again, thinking about velocity, it's really easy in an organization like ours with a security posture that's really tight to just stifle workflows by not allowing people to do things. But again, that's not very cloud native. Like, how do you enable people to iterate and experiment with the freedom that they need, but also maintain your security posture? The answer is difficult, right? So the approach that we took is segmenting out development entirely. So we have a separate G Suite domain and a separate Google Cloud Platform organization linked to that that's just not accessible from within 2 Sigma. Like, you have to be on our guest network or on an unmanaged device to access that environment. And what that gives us is the ability to allow people the freedoms to have the privileges that they need to iterate and develop, and also protect our IP, because you can't get to our IP from there. So that ultimately led to even better workflows for us, because then when we have a new team or a team that's considering a new project, they already really understand what it is they need from the cloud platform and IAM, and could just tell us that, and we could easily review that, approve it, and roll it out. Again, I talked a lot about being cloud native. Again, there are obvious security trade-offs here, right? If you want the ultimate set of control, you'd build everything on top of Google Cloud Engine VMs, and then you maintain pretty much as much as you want. But there's a trade-off there, right? Then you have to worry about administration, you have to worry about patching, you have to worry about vulnerability management. The trade-off there is to use completely managed services, something like Dataproc, where you don't have to worry about any of those things. But in turn, you lose that level of transparency in the stack. And, it's difficult. There's no right or wrong answer. Every use case is business risk dependent, data dependent. But the key thing as a security team is to understand what those trade-offs are and present them to the business so that the business can make the appropriate decision based on the value of the project and the value of the data. So again, cloud native controls, really our posture is wherever we can use something that Google's built, they'll support it, develop it, and maintain it better than any custom hacks that we'd have to put in. So that's our preference. Layered defenses, again, I spoke about defense in depth extensively, so I won't spend too much time, but you don't want to be in a position where a single compromise or a mistake or even a failure on the cloud provider side would lead to you having a really bad day. If you're one mistake or one compromise away from being on the front page of the newspaper, that's a bad place to be. So the more that you can layer defenses, even if it takes more work, even if it's unnecessary, like, I like insurance. We have an insurance business, so I'm in that space. And the last takeaway from us is it's important to move fast. again, a lot of organizations that are very security sensitive have a tendency to take a lot of time in review, and rightly so, the analysis and getting in depth. But again, you're blocking the business's velocity. And people are going to find ways to work around you if you take 6 months to review one new service. So find workflows. And again, to borrow a quote from somebody else, Jason Chan, who's an engineering director at Netflix, he said security's job should be to build guardrails, not gates. So ultimately, we're not there yet, but my team's goal is to enable none of our developers to have to think about security at all. We could just build a platform. We can work with our partners, Google, to build a platform where developers can just do their jobs without ever having to think about security. So on that, I'd like to hand back over to Alfred to wrap up with some final thoughts and final notes.
So I hope you got from that sort of a couple thoughts. One is we were pretty early adopter in this, and you heard about what we did in that stage from Jacques in his presentation. When I got to 2 Sigma just about 3 years ago, we effectively didn't use the cloud for much of anything. I don't know, maybe a couple of tiny things. And we were fairly able, because of Jacques and a few others' work, to get to a situation where maybe half of our compute load was sort of on the cloud, although we did it in ways that were not as cloud native as we would like. And we were not able to fully use all the services that we knew that were coming. As we got to the second phase of this, working more closely with Google, we were able to use standard technologies after certainly providing input as to what they should be, but able to use those. And now we've gotten to that stage where not only are we doing a lot of compute in the cloud, we're doing a lot more heterogeneous computing in the cloud, using a lot more different services. And we do think that's the future of all of this, is that I don't think any of us, unless maybe we're Google or a very, very large company, can build all the things that we will want to use. They're just too big. We can't build BigQuery or something like that. It's a huge project to go do. So we're very excited about the future. We think that Google now understands a lot of these principles of that really come from the notion that ensuring that data is not universally accessible and useful. That's not the only thing, right? You need to be able to control that access, and you need to be able to control it in a way, as Nick said very eloquently, that you're not one mistake or one attack away from being on the front page of the New York Times, as it has been said. So we certainly don't. We think that seems to now be the case, and we're very excited about being able to rapidly move forward in a lot more fronts. These are the talks that we're giving. So on the security, I guess it's already kind of late on Tuesday, so without a time machine, you can't go back to the earlier talks. That we do not have. If we did, that would be quite interesting in our business. On Wednesday and Thursday, you'll see the talks, though, that are listed in security and, as I mentioned, the serverless computing talk. The Halide talk, I think, is at this same time slot, right? It's also at 4:35 in the afternoon if you want to have some fun and see how maybe AI will continue to be explored in ways that are really challenging. So we should open this up to some questions after the obligatory "we're hiring." We do exciting things, as you can tell. We're trying always to be on the forefront. More than any other firm that we know of, we get to answer the question with all of the security and computation, what is the effect of machine learning on AI in the entire world of economic optimization? No one knows the answer to that question, in my opinion. I've been in this field leading research teams for many decades. We know small areas where it's useful, but we don't know the breadth. So the firm is dedicated to some really interesting problems that, if solved, will make economies in the world, I think, far more efficient and make our firm very successful. So thank you very much for your time. Let's take some questions if there are some.